Hey friends, if you like the Nexus podcast, the best way to continue the learning is to join our community. There are 3 ways to do that. First, you can join the Nexus Pro membership. It's our global community of smart building professionals. We have monthly events, paywall deep dive content, and a private chat room, and it's just $35 a month. Second, you can upgrade from the Pro membership to our courses offering. It's headlined by our flagship course, The Smart Building Strategist, and we're building a catalog of courses taught by world-leading experts on each topic under the Smart Buildings umbrella. Third, and finally, our marketplace is how we connect leading vendors with buyers looking for their solutions. The links are below in the show notes, and now let's go on to the podcast. Hello, and welcome to the Nexus podcast. I'm your host, James Dice. We are kicking off a new series leading up to NexusCon in the fall, focusing on different vertical industries and how their smart buildings programs are similar, different, and really just digging into the different trends in each industry. So in this episode, we have higher education. So we have 3 higher education institutions in the United States here. They all have different varying degrees of smart buildings program maturity and deployments and lots of different projects going on. So we're going to dig into those and talk about the trends in higher ed and talk about, sort of what these 3 are thinking about. So let's do some self-introductions here. Let's start with you, Gerry.
Hi, I'm Gerry Hamilton. I am the Director of Facilities Energy Management at Stanford University. In addition to running our building side energy programs, I also oversee our Facilities Automation Center, our building controls group, as well as a small team called Business Systems that administers our utility data historian. So combination of energy and automation and a little bit of data management, kind of in a front row seat here at Stanford for our smart buildings work. And happy to be here, James.
And Gerry's been on the show before. We have 2 newcomers here. Dan, why don't you go next?
Hi, James. Thanks for the invite. My name is Dan Quigley. I am the Director of Engineering and Building Systems at Boston University, which basically means I oversee the mechanical, electrical, plumbing, automation team, engineering, and energy groups. We focus on, from a building automation or a smart buildings perspective, migrations of building automation, as well as standardization through our construction and retrocommissioning teams. And I'm happy to be here as well.
Awesome. So we went West Coast to East Coast. Now we'll go Midwest. Durga, go ahead.
I'm Durga Sarilla. I take care of the controls lead for the Kansas State University. So I take care of the most of the controls operations for our whole campus. It's really the building automation system, kind of all HVAC, fire, and security. And we work along with the large stakeholders, like with the planning team and everything, to provide good control systems in the campus. And we work the energy management team to integrate with that system. So we have separate division which work with us, and the part of building automation side on the energy management.
All right. And you guys have hinted at it here. I've heard a lot of energy management. I've heard a lot about building automation so far. But can you guys talk about sort of what smart buildings mean to your institutions? Like, what are the main goals? If you were talking to the chancellor or the president of the university, what would they say about why smart buildings matter?
I could jump in. So I certainly see smart buildings as like a collaborative effect. It's a group, not just like one individual trying to bring smart buildings to a campus. There's a lot of stakeholders involved. We have to consider the construction team, the engineers, obviously the building automation, electricians, HVAC technicians, the operators of the buildings, as well as the end users, senior leadership, and finance, right? So there's a gambit of stakeholders when you talk about the buildings at universities and pretty much any institution, and how you would sort of implement a smart buildings program. When we think about our goals, we think about how do we maintain our existing infrastructure as well as build new construction, so that the BU community, the Boston University community, or anybody in our buildings really are comfortable. They can work, they can live, they can play, do research, and not have to worry about buildings, all while we're trying to optimize our buildings' energy use through different smart technologies to reduce our carbon emissions. So when you kind of ask the question, when you're talking to the president or chancellor or senior leadership, the goals are going to be, how do we reduce our energy use for energy savings and cost savings? But maybe more importantly, how to reduce our carbon use while maintaining one of our main goals, which is having a community and a physical presence on a campus. So don't take one side and compromise the other. So it's really a collaborative effect.
And in higher ed, yeah, it's great, Dan. In higher ed, there's the students, but then there's also the faculty, right? So, and there's almost two different populations that you need to keep happy. Gerry, what about you at Stanford? Is it different, similar?
Well, Dan, that was very well said. I think kind of to add to that is we've tried to be as pragmatic as possible because it's so easy to waste money on kind of technological dead ends. But I found even more important wasting staff's enthusiasm or wasting their effort if they're so busy trying to engage with new tech or do things that appear to be pet projects, it actually sets us back. We get less done. We spend more in internal resources. So, for us, just to throw some specifics out there, by 2016, we launched a program we called the Integrated Controls and Analytics Program, and very, very, very dry name, but it was focused specifically on, we're concerned about the automation systems in our buildings, so let's focus on that. We're concerned about how to overlay kind of a first generation of analytics on top of that data, so let's focus on that. Let's not boil the ocean. We have all these other stakeholders that you've referenced to. We can't meet everybody's needs, and so we're several years now into a program which initially really prioritized coming up with good, simple, scalable, affordable, maintainable standards for our automation system, ensuring that those can actually be successfully brought online both for new construction and in retrofit projects. So we've got a long pipeline of upgrades we want to do. And our objective is, number one, realize the energy savings and the carbon savings that we know we can get from modern automation systems. And that's still our best energy efficiency measure. Very practical benefits like that. We are now kind of moving into more tangible benefits related to operation and maintenance. That's a little bit more challenging than objectively saving energy. But I guess the point is, keep it simple so that we can continue to scale and build upon it and try to avoid dead ends, which ultimately just leave people frustrated.
Yeah, so I'm hearing themes around energy and carbon, so furthering sustainability goals. I'm hearing a little bit around, Gerry, you're hitting at sort of the maintenance and technicians, job satisfaction and productivity, hitting technology for those reasons. And then this other broad theme around experience. So Dan, you said comfort, the people that are experiencing the buildings. Durga, is this similar to kind of what you guys are trying to accomplish with technology?
It's almost similar thing, like Gerry and Dan have already written points on a couple of things. Mostly these universities, we see the revenue is mostly generated from the research and enrollment kind of a thing. And to get that kind of revenue, we need to provide the facilities to generate that revenue, right? So the smart buildings program, everything will be trying to focus on those kind of things, how they can utilize those facilities much better way to do their research. And so we need to provide that kind of air conditioning, safety levels, comfort, and again, looking at the point of energy efficiency kind of things too. So all these three parameters, focusing will be mostly the part of this smart building automation too. But we can't say, as you said, because James, I have followed all your episodes to before, when you're discussing about different parts, about different silos. Currently, I know the universities, for example, for our university itself, we have a control system which are 45 years old, we're on pneumatics, and still a couple of the things are on pneumatics where we can't integrate with each other with the current DTC systems. So that's a smart building automation comes into place where we can replace it or use the smart building program to integrate or communicate with these all together to provide kind of the safety and the comfort levels, and what our goals towards the sustainability or the carbon net zero, what are those jargons we are trying to use here. Yeah, that's a point I was trying to look at.
Yeah, totally. So yeah, and Gerry mentioned lots of upgrades as well. So that it's all of this is sort of integrated in with O&M, but also capital improvement projects that you guys are, whether it's a new building, a renovation, or actually just upgrading your infrastructure, like you're saying, Durga. Let's do a little bit of survey. So those are sort of the outcomes, like why you would use technology in higher ed. Let's do a little bit of a survey around what types of technologies we're talking about. So we've been talking a lot about HVAC control, right? What are the other, let's just sort of run through the things that the technology categories that are on your guys' minds right now. What else are we talking about?
HVAC, fire, security, elevator controls, and wastewater management, and kind of all the utility side. And if you say I feel most of the university having their own chill water plant and the hot water plant. So that would be the major chunk which gonna use a lot of energy over there. So those are a couple of areas I would see, and kind of demand ventilation. That's one thing after COVID, which is really been really important here, providing required fresh air for all classrooms and labs.
Those are a lot of what we call, yeah, you said silos earlier, Durga, the different silos, different devices or different control systems in the buildings. What are we missing here, Dan and Gerry?
So, I mean, we're using building automation systems throughout our campus. Lighting control systems are kind of getting in our buildings through Energy Code and Boston Stretch Code. So that drives a lot of the lighting control system installations. Monitoring-based commissioning has been, sort of matured a little bit over the past couple of years, but we're starting to use it more and more with our capital projects, our retro commissioning and major ground-up construction projects, or even complex projects like lab renovations or chilled water plant optimization, where we see value in sort of capturing, obviously, issues with spaces, but also from an owner perspective, monitoring-based commissioning with fault detection diagnostics, if implemented early enough in the process, we can capture issues during a warranty period where it's like 1 year after construction is complete. And, seasonally, we can see how things function. And if it's captured and identified in monitoring-based commissioning sort of audit system, so to speak, then contractors will come back and sort of fix those issues with no cost to the owner. So I've been using that as sort of a huge sales point for monitoring-based commissioning internally versus the sort of traditional energy savings and cost savings through drifting of buildings. So that technology is sort of getting implemented at the university. And something else we're interested in is automatic functional testing, sort of using the cloud and functional testing to sort of communicate with our automation systems, drive them to, valves open, valves close, see if sensors are operating or valves are operating correctly, and report back. So to help our team, I know we talk a lot about automation and HVAC, but really help our HVAC team focus their time. To kind of touch upon what Gerry mentioned earlier, our workforce is challenged with time. So we need to help them sort of prioritize their work lists every day and say, well, this is what's failed in that building. Don't just look around all building for hours and hours. Go directly to this valve and this piece of equipment. Anything we can do to optimize their time will help them be successful and help us produce a better product for our customers, which are the occupants and end users of these buildings. And that's all they really want, is a space that they can be in that's successful, and so we can make everything good for them.
Yeah, such a great point. I think what you're highlighting too is the importance of FDD being used for all these different things on campus. That's something that I've noticed as we've interviewed Gerry, interviewed other higher ed leaders. FDD seems to be applied in a bunch of different ways in higher ed, which, if you look at other industries, is more advanced in the way that it's being applied versus others. And it seems to be more accepted as a normal piece of the pie, a normal piece of the infrastructure. Gerry, what are we missing from your program?
But one area that we're dabbling with now is really trying to make strategic sense out of wireless distributed sensors. The big topic now is indoor air quality. But I'm also seeing innovation in technology that can provide smarter occupancy monitoring. So we're not just it's not so much binary anymore. Is somebody there or not? It's kind of like, well, where are they, or how many, or what's happening in the space. And challenges we run into is that there's privacy concerns. There's also there's legal ramifications of the data. If we suddenly start collecting a lot of space data and maybe those numbers don't look good, what are the obligations to fix? And it's a whole new area, and we're stumbling into, again, management level challenges that I never envisioned. I mean, what would be wrong with putting a new smart sensor out there? So these are kind of change management things we have to go through. But also we've got to learn, what are we actually going to do with the data? Are we just going to be cluttering? Are we just going to be making more work for folks? So, you've heard the wildfire stories out here in California. And so in the past few years, we've had to deal with, particulate and things. And so that's good information to have. But, how do you respond to that information? Are there thresholds? Are there criteria? So it's opening up all new avenues of discussion. Plus, you got to manage the data itself. Where does it go? I'm really concerned about the future in our industry of, wireless IoT devices. Wi-Fi doesn't appear to be, the right long-term way to manage this. But, what is the perfect operations network? And I don't know if that's even been defined yet. So I wish I had the answers for you all, but that's an area we're giving a lot of attention, because I think this can help augment our existing HVAC systems and processes, but we can bring in a lot more people to the smart table, people involved with space management, safety, health and safety, all these things. I do want to put a plug in here early, because one thing that we are spending a lot of time, it's not a device, it's not a specific piece of technology, but rather it's software related, it's data management. And what is our plan for ingesting all the data from current and future systems? What are our standards? How do we manage those standards? Because one thing we've learned, accessing data isn't the challenge. The challenge is consuming the data. And one thing that we've burned a lot of staff time on is, once people have access to HVAC data, if that data is confusing, if there's gaps in the data, if they lose connectivity, if they don't know how to interpret the data, then suddenly the subject matter experts, whether they're energy engineers or whether they're controls engineers, are having to spend a disproportionate amount of time supporting individual consumers, supporting individual applications that consume the data. And so we've been trying to get ahead of that and invest in software and practices so that we can ensure that the data is easily consumable, because I see that as an area for big opportunities for overall labor savings going forward.
Yeah, and it could be, what you're saying is, it could be a student that's not doing research, or it could be a commissioning agent on the new renovation. There's a bunch of people that could use this. Dan, go ahead.
I just wanted to echo Gerry's point with data. Is we are literally in the same position. I had a meeting last week about how we're going to store all of our utility data and how we're going to allow people to access it, and sort of what platform we're using, and how it's being consumed. And it's just a huge conversation, because our buildings have all this information. We have all the sensors in building automation, lighting controls, utility meters, and things of that nature. And it needs to go back to not necessarily a single interface, but a trusted interface, and put it into a consumable format for people to understand. And that's kind of our challenge right now. So I just wanted to echo Gerry's point. We're on the same page.
Yeah. So we've talked about device layer. We've talked about data, like what we're talking about right now is in our parlance at Nexus, the data layer. Durga, do you have data layer interests and concerns as well?
Actually, like when Dan and Gerry, they're talking about, once they brought to the challenges part, because we being a small institution and we have very limited amount on that. So while we are focusing on this kind of data thing, like bringing all data together or going with a third party, people who are going to provide us, is being a challenge with them. But for me, like when I talk about, I talk as a controls guy because from a controls background, I see for me, I like to fix the foundation level issues because we have different types of controllers here, different from like 40 years old, where we can't integrate the systems or something like that. So when coming to point of a data layer, okay, if there is no integration between devices, how we can get the right data to give the right decisions for the system. So if you take, like, for example, if you take a long backnet and there are some proprietary protocols, so these proprietary protocols cannot integrate with the backnet or something. Though we have some device, what if there's a communication loss? At least if you lost the communication for 1 hour on the data layer, how can we get the right data to give those decisions on the enterprise layer on the level? So those are a couple of challenges like I'm looking for. So that's one reason we haven't started anything on bringing on the FDD part or anything that FDDs or any new technologies into our systems. What we started doing is like trying to clear the issues on the foundation levels because the controllers itself have a capability of clearing all these field level issues with the programming or something like that. On top of that, if you provide the data layer, then it's gonna give a right value for the data. I mean, 10 years back, though we had the systems, but we have this phantom which got all these alarms and everything. And with those alarms, we can create a work order says we have this exact issue. But I know this technology is reducing that kind of a 1 hour time into 50 minutes time for the person to work on it to know where the exact issue is if the foundation layer is not really good, I feel like we won't get any right data about the data layer or something like that. So that's one challenge I just want to put on.
Yeah, it's almost like a hierarchy of needs thing, right? You can't move up the stack until you feel like you have the foundational layers of the stack correct. Gerry and Dan, I bet you have something to respond to Durga here around. I doubt that your device layers are perfect before you're putting a data layer or thinking about putting a data layer on top. What would you say I think there's something around not letting perfect be the enemy of good here. What would you say?
Well, I would agree. I've been at Stanford 14 years, and you never get caught up with anything, right? And as soon as you start thinking you're making progress, suddenly the projects you did 5 years ago are old. And so I do try to break things into components. My staff hear me use the word modularity a lot. And in fact, as we learn more about technology, I try to break things into different components. And so, for example, data management, it's its own thing. And in fact, we're even separating it from our fault detection and diagnostic system. And as the more we learn, we realize, well, there's a whole art to extracting data. There's a whole art to transforming the data for our needs to make it consumable. And there's a whole art to loading that data to the various applications and consumers who need it. And I believe that progress can be made in each of these areas, even if maybe you have some problems in one area. So that the clever part is kind of breaking it down into components so that you can be pursuing, best of class in each of those without being hamstrung. So I guess my advice is resist the temptation to go turnkey macro level solutions on everything, because you're guaranteed that, a couple of the modules in there are going to hold you back, and it's going to be frustrating. Otherwise you do get, tied up on this concept of if everything's not perfect, then nothing's perfect sort of thing.
So I agree. I think it's when we're talking about data and, how do we not get caught up in fixing everything in the past? And you kind of have to sort of stop the problems going forward first, is the way we've always approached it, through standards and documentation, working with our construction team so that new construction and renovation projects and retro commissioning projects that might be led from like a bigger perspective on the campus, they're going forward with the right standards, right? They're moving forward with correct point naming. And then all you have to do from your team is sort of look back and say, okay, how are we going to attack our aging 30-year-old proprietary control system? How are we going to attack our early version of BACnet that maybe doesn't function so great? And how are we going to approach our pneumatic system and Durga, you're not alone. Our campuses are very old too, and I have pneumatics. I have a Honeywell controller running an air handler that's the size of my door back here, down in one of our old buildings, and it's got like the whole schematic display and pneumatic gauges and everything, and it still works, and it's on our roadmap. But the way that we approached it, first and foremost, was standards and guidelines and documentation, so that everybody involved, from the construction perspective, new construction renovations, to our system integrators that we use, to our internal team, everybody's using the same language and the same standards going forward. And I will say that the controls companies today versus the controls companies even 5-10 years ago have really transformed what their standards look like. So the standard point naming is really not an issue anymore, as long as you're working on the same standard packages from these control systems. So it's getting everybody sort of on board with the right practices and standards, and then sort of letting the groups kind of do their own thing, so you can approach things in parallel.
Yeah, I think I'd echo that based on all the conversations I've had around, like, okay, if everybody, Durga, in higher ed is wanting to get to FDD, it seems like to me, everybody I talk to has got that on their roadmap at some point. You can't wait till you have every controller the latest version of whatever DDC standard you have before getting in that direction, right? Just use the data you have. Eventually you'll be able to upgrade that controller the size of a door, Dan. And when you do, it can get brought in, but it doesn't need to get brought in right now. Let's shift gears a little bit. I think this is a really fun conversation. I didn't predict us being able to offer each other advice, which was an emergent quality of this conversation, which is fun. Gerry, I want to circle back a little bit towards the space utilization point that you brought up here. I feel like when I talk to people that are thinking about smart buildings in higher ed, it's mostly around energy and HVAC control, metering, FDD. You're talking more about front of the house in a way, at least what I understood to you, what you were saying. It's not necessarily about counting people or figuring where they're at so that you can control HVAC better, which could be a use case that you could use with those sensors. But you're also talking about working with other people on campus that are thinking about space planning and where students are and where they should be, and maybe safety. Like, there's a bunch of other use cases that you're thinking about here. Can you expand on that a little bit more?
One of my objectives is to increase the number of people around the table that I get to sit at when we're talking smart campus. So it's not my table, right? We've talked before, there's a lot of folks here, but and it's a lot of work and it's stressful, but I know I got to think beyond HVAC control, lighting control, energy management. And Stanford's a big place. So we've got silos. The folks who manage door access are different than the people who manage the fire systems. And there's a lot of us. But even then, how do we get outside of the traditional building, operational technology space to talk to people who are involved with space planning, that are involved with environmental health and safety and public safety? And I don't exactly know where that conversation is going to go, but I do know when we are stuck thinking, what do I do next? There's so much that's wrong. Where do I start working first? It actually is a lot easier if you can narrow that down to one or two things that have big benefit to a large audience. And I think, managing the spaces is it. Certainly in higher ed, we all refer to buildings and we all refer to the spaces. And conversations I've had with some data governance folks who are concerned about student records. They're concerned about, privacy issues. So what do we have in common? I go, well, you refer to who's in a space, right? And I refer to the VAV box in a space. We should probably have a standard to refer to that space, right? Because if we're ever going to share data, we've got to have some sort of ontology that makes sense. Like, oh, maybe you're onto something here. I've had conversations with environmental health and safety about these wireless controllers and what can you do with it. And they say, well, do you have something that can, measure hotspots? I want to know if, there's a temperature on a bench that ever gets above a certain point. And I go, well, I think that technology exists. It's made by folks who use that technology to see if a human being is there, right? Because they measure the temperature. And so suddenly there's co-benefits of technology that nobody had envisioned. Talking with some of my facilities operations partners, they're interested in monitoring indoor air quality so they can assess the thoroughness of cleanliness of their spaces. They want to be able to measure the chemicals in the air. They want to know that this place was clean. Not that there's a toxic level of cleaning chemicals, but they just want to know, was it clean? Did somebody come through here, right? So if you don't have these conversations, you don't find these overlaps. And so the final driver for Stanford might not be a better occupancy sensor for lighting control. It may be finding human life safety issues or near misses or supporting custodial practices. Oh, and by the way, we'll just pull some of that data into the HVAC system and the lighting control system. So kind of instead of me trying to push something, I could pull, or I don't know what the analogy is, but there is a lot of overlap out there, and you just got to start these conversations because everybody's trying to do something. I also like to go out there and point to folks, we're not trying to make our occupants suffer. There is so much benefit that we can still achieve from an energy perspective just by, better operation. And I think maybe something I'll queue up for a little bit later where we're looking at dynamically managing room level schedules. And again, not that we want people to suffer, but we just want to operate our assets smarter. And we think occupant comfort is also an area where a large audience can rally around. And even I'm the energy manager here, and I said, no, people shouldn't have to wear sweaters in the middle of summer, right? Or, they shouldn't have to dress uncomfortably. We should be able to get the utility out of these buildings, and we should be able to do things like manage our rogue zones or our dominant zones a little bit smarter. And that's where the smart comes in.
And this is awesome to hear you talk about, because this is really the crux of the smart buildings problem. So in the past, we had all these different silos on campus, all these different systems. And if you were going to put an occupancy sensor in for lighting, it would be the lighting control system's occupancy sensor in that sort of siloed paradigm. But what we're talking about is let's think about all of the technologies that are available to us and what are all of the different outcomes and use cases we could use with that piece of technology. And Gerry, it's also silos within our organizations, right? Where you're saying who do I need to go talk to? Let's bring more people to the table. Dan, how does this work with you guys? I see you kind of nodding your head a little bit. Maybe the same themes are popping up over there on the other side of the country.
It's very similar, right? We have different parts of our organization, but we've been working at it, at least in the last 10 years I've been at Boston University, we've been working at sort of breaking down those silos and being more cross-functional and making sure that everybody's needs are heard. So, Gerry, you were talking about how, how does this piece of technology fit at the university? Well, you might not see that in HVAC or lighting controls, but maybe there's a safety need for something like that. And is this the right technology for that safety need? Or is it, using some sort of camera, and maybe the security team knows more about that? But sort of building those bridges internally has been a big goal of ours over many years. And it's working really well now. We have those conversations, Gerry, that you're talking about. And if you don't, then you're missing opportunities to make your process a little bit more efficient and productive. And also being able to present the senior leadership a multifunctional solution, right? You're not talking about just energy savings, but hey, if we install new building automation controllers, it'll reduce our energy and it'll have a more comfortable outcome because we're using ASHRAE guideline 36.1 programming schema that backs down on that VAV box so we don't overcool the space, so they don't have to wear sweaters in the summertime, sort of thing, right? So there are more than one solution. We just have to kind of pull it out from the different parts of the organization. And we've been pretty successful with that for the years, but similar themes for sure.
I want to switch gears here. Durga, do you have anything to add before I do?
I feel like when I'm listening to that, everything is similar on the higher head. It's always when we do any projects or something, it's we are trying to bring all stakeholders together, because it's a multi-organization, it's different departments, they have their own requirements. So it's we are bringing all together, and I feel we're trying to integrate those at one part to provide what they need actually. Oh, the one thing I just want to say, I think recently we had our custodial team working on our indoor air quality monitoring. So they had got their own separate technology for them, like they bought their own products that they're testing it now. But what I'm trying to think is like integrate with the building automation. So they have their own product, but how we can integrate with the building automation so that they all communicate with each other. So those kind of things we are trying to see here. So.
And are you involved in that project as like one of the controls leaders or automation leaders? So you're getting pulled into the custodial team's project. Yeah.
So most of the things, like if you say like all different organizations we have here, I'll be trying to pull in because they all bring out different technologies, different products inside. But I'm trying to push here to get it in one place so that everyone has information and they can work together. So that's kind of one kind of a mindset I'm trying to build with the people here, with the organization, so that everyone can work together and have right data for their decisions.
Totally. It's not just stakeholder engagement, how we kind of view stakeholder engagement as one step in the overall creation of a holistic strategy for the campus, right? And it's like, okay, well, what are all these different perspectives and people that are getting pulled in to sort of create and update and maintain that strategy and vision for how technology is getting used on campus. Let's shift. I want to let you guys tell some stories of recent successes, and I'd love to just hear if there's like one project that comes to mind immediately on like, this was a huge win recently. I'm going to ask you those, but then what we're going to do after that is move straight into the biggest challenges as well. So maybe Gerry, you want to kick us off? So, sort of think about what is a project that just got done or recently got finished that you would say is a success story, and maybe also talk about the impact that it has on students and faculty as well.
Well, I think I have a good example. It touches on several aspects there. So we're a few years now into a joint research project with an academic team. And we initially were looking at smarter control of chilled water consumption in our buildings and doing some smart load management at the room level. So since we've got modern HVAC systems, and we've got some analytics and some point naming and tagging standards, how do we do that? And we have district heating and cooling here. So, we are concerned about the distribution and consumption of chilled water as a utility resource. And I've never had a successful project with researchers before. Usually, either I'm being selfish or they're being selfish. One party gets all the benefit and the other just gets a bunch of work. But in this case, and maybe it has to do with the smart buildings aspect, because we're using this new infrastructure we have, we're applying new data management techniques, and both parties weren't afraid to, bring their strengths to the table. We know how buildings work, we know how the control systems work, we know how the market works and the market limitations. The researchers are bringing, smarter, better ways to manipulate data. They have the time and resources to test algorithms. But what was nice is, operations, we weren't afraid to say, listen, this is the limit of our knowledge of technology. This is the limit of what the tech can do. What do you think? They were brave enough to come to us and say, listen, we really don't know how your market works. We admit that, you operation folks aren't dinosaurs. There are real modern issues that need to be dealt with. How can we help? And it started a very constructive relationship. And I think it was the fact that, hey, this is a real world scenario. With a third or more of the energy is used in commercial buildings. We've got to address these market challenges, and it's not just we're lazy, not willing to do the right thing. And so we're 3 years into a program. It started as the Cooler research program, and we're really springboarding upon this because we are able to do some room level management. And at Stanford, we have 600-700 buildings on campus. Usually we're looking at the top 200, but you could have 100 plus rooms per building. So tens of thousands of spaces that we want to dynamically modulate and control, on a fairly fine time scale. That is a big data problem. There's quality control issues. You can't be disrupting occupants or research. But we're working with some real researchers now to address these challenges. And Mostly it's coming down to data management or how to get information from one area over to another area and ultimately pushed into our control system. So we've still got years of work to do here, but we found that by just tweaking set points here and there in non-critical spaces, we can save 14% or more load, and basically to the point nobody even notices. And so if we're trying to manage emergencies, or if we're trying to do some peak shaving so that we can enable, electrification conversions, there's a lot of benefit from being able to do this smartly. Next thing we want to do is dynamically manage room level occupancy mode. Can we toggle spaces more aggressively from occupied to unoccupied to standby? But there's some change management there because it takes a village. We're going to have to manage data from potentially tens of thousands of occupants. That's not something, HVAC operation folks have typically felt comfortable, allowing to happen, right? But in a modern realm, especially in higher ed, we get questions like, as occupants, what can we do to help? And, there's a lot of opportunity here. So that's been a big win. And hopefully we can continue. And maybe it's just magical. Maybe we're just lucky. But I do think it has something to do with the fact this is applied, cutting edge technology addressing real market challenges, in the commercial building / higher ed space. And we're gonna keep going.
It's fascinating. So if I understand what you're setting out to dynamically control every room's set points based off of some outcome, and the outcome could be just simply minimizing load, like you said, but it also could be load, like demand flexibility of the campus as well. It sounds like if we wanted to start controlling spaces based off of renewable energy on the grid or your demand, strategy. And it sounds like what you did was initially just test it out. Can we do this in a couple spaces or a couple buildings or one building? And it sounds like it was a success. And what I'm hearing also is that it doesn't sound like this would have been possible if you guys wouldn't have gone down the road you went that we were talking about earlier, which is like, let's create our own data layer. Let's start to normalize all the data. Let's tag all the data, getting it all in one place so that someone like a smart researcher could come in and start to manipulate it for the purposes of that project.
Exactly. They were able to plug into our automation system. They were able to plug into our FDD platform and use those as a starting point. And we've already come up with ways to improve those. But the main thing, they weren't afraid to look under the hood. They were motivated, right, because of this technology. And so, and the other thing is, again, we are looking way beyond just efficiency now, right, and resilience. And there are a number of reasons why we may want to manipulate load on campus. And one benefit is if we can manipulate load at the entire campus level, that may avoid us having to actually shut off one or two or three buildings completely.
All right, that's what's on Gerry's mind. Dan, what's going on with you? Any recent success stories?
Well, I don't want to breeze past Gerry's awesome name for his program, which was Cooler. I think that's a cool little pun that got thrown in there, and I appreciate that. That sounds very impressive, Gerry, what you're doing there. It's difficult to look at an entire campus and sort of respond to like the demands in space to really back everything off and be dynamic about it, like you're talking about, at scale. And that takes a lot of effort. So, kudos to you and your team, first and foremost. I have a couple of projects. I know you said just one, but the way I kind of looked at sort of case studies or success stories, I broke it in my mind as two different groups, like new construction, ground up capital project, and then sort of like an existing building, because I think they're two different challenges, really. New construction, we just finished last year a high rise in the city of Boston that people call, when they were going down Store Drive, the Jenga building, because it's got a lot of cantilevers. And we don't call it Jenga because Jenga towers fall over. We like to call it the stack of books building, but to each their own. But it is the largest carbon-free or fossil fuel-free building in the city of Boston, I think in the Northeast. And it uses 31 1,500 foot geothermal wells, going back to a VME2 heat recovery chiller and providing the heating and cooling for the building all electric. There's not a gas pipe in the building, so fossil fuel free. And so that's a huge success for us at Boston University and our climate action plan. And I think from a look at sort of a smart building perspective, to make that work and make everything work in concert with each other, from the over 700 active chill beams to the 4-5 air handling units, to the heat recovery chiller, and then the expandable peaking sort of electric boilers and electric centrifugal chillers and cooling towers, all of that to work together was very impressive to me. And sort of like that was a great success. And our energy use is very little because we're using that geothermal as our primary heating and cooling sinker source. And one of the, you kind of touched upon the different organizational components of a building. You've got like the electrician installing lighting controls and HVAC and BAS installing the automation controls. One thing, we sat people down early on in the process and we said, hey, lighting control company, part of your scope is to work with this building automation company and zone out the HVAC zones and give very specific data points on which aux sensors are going to enunciate or activate the HVAC. Because often what happens is they get to the end of the project. These are two companies that are very late into the construction project and they want to get off the site. And we're like, no, sit down, grab a highlighter, work it out. And that was a sort of a small but good success within that project as well. So new construction, I think from a sustainability perspective, it's a great building. Smart building, it's all functional BAS and lighting controls. From a existing building, more recently, we took out an older sort of legacy 30-year-old building automation system in our track and tennis center, which is about 100,000 square foot building. Beautiful track, tennis is played there as well, obviously. And big old dome, open-ended ductwork, no VAVs, very simple control, heating coils. Never really had many problems with it, but we didn't think it functioned correctly. So when we started to look at the original sequences, the programming in the old BAS, and we're migrating to the new BAS, we thought of things a little bit differently and how we can operate the building. And we said, well, maybe we'll turn heating and cooling systems on based on demand from the building, right? It's a small enough building. We know when there's demand. We'll look at just that and sort of versus just a standard outside air trigger. And we'll shut things off when they're not being used. And those small changes, plus maybe some modern air handler code, is saved over 20% energy, electricity, and 40% natural gas usage in the last 6 months. So this is huge savings just by a small migration from a old legacy control system to a new one that's modern that we're going to have to do anyway from a maintenance perspective. So it gives us the opportunity to think more intelligently about our buildings. So those are kind of my two categories of success stories.
Yep. I like the measurement success story with the number of people we have and the amount of limited funding we are getting to get do our daily operations. Because for us, if you say we are just only like 4 people on the control team, we're going to take care of 6.4 million square feet for the building automation. Just the 4 people, if you think on that. So, and very little funding to upgrade most of things. So if you consider that we are trying to do the best we can do to get our systems up and running most of the time, probably. So me being on the side of the controls team, I mostly work on the control side of the programming. So trying to reprogram most of the stuff where we can save some energy savings, like integrating all the valve controls and everything with the hot water system and the chilled water system kind of a things. And utilizing campus scheduling program integrating with HVAC systems, which probably has given like 20% savings on the energy when we're trying to use the room, especially for the classroom scheduling, integrating with HVAC. We haven't been running those HVAC systems 24/7 when there are no classes. So, which really provided great savings on this. I would say that is kind of a little bit of a success story on our side. But I would like probably say with 4 people and trying to do this operation maintenance for all these buildings, I feel like it's success for everyone in our campus.
Yeah, yeah, totally. I think I'd love to talk to you later about the room scheduling integrating with controls. I think that's an area where I'd love to dig in more. In the interest of time here, what I'd love for you to do, each of you, to go back around and say what your number one challenge is with your smart buildings program. So it could be workforce and people retiring and the time that they have. Could be not having enough people and funding. Durga, you said it sounds like that might be yours. Could be making the business case. It could be integration. It could be change management. So just, I'd love for you guys to go back around, Gerry, if you could start. And what's your biggest challenge?
So many, right? The challenge we're working on now, and I would call this an opportunity, and again, this is at the leadership strategic level, is better collaboration between our OT platform owners, lighting controls, HVAC controls, door access, you name it, and our IT application professionals. And I call that out differently because, around 2015, we had a big breakthrough with our IT infrastructure support team. We realized it's much easier for them to manage the networks that our controls run on. Let's work with them to do that. It's much easier for them to manage virtual servers than us having physical machines in our buildings. And of course, we need this for resilience and security as well. But huge labor savings, huge breakthrough, almost 10 years ago now with this OT and IT collaboration. But now as we talk more about managing data and trying to simplify these software tools that we've got to manage, what's going to be that next breakthrough from a staff efficiency, economies of scale sort of thing? And, basically, how do we get these OT folks working closer with people who manage things like, asset management systems, GIS systems, CMMS systems, managing users. That's a pain. Managing patching, upgrades, managing software contracts. That's a lot of work. And if you step back, it's kind of silly that we're all doing these in silos. And so, building on the success of kind of the breakthroughs we had on the infrastructure side, what can we do on the application side to collectively make life easier for us? Where we're going to go with that, how we're going to get progress, I don't know yet, but it's a challenge that I'm optimistic will be a good opportunity.
Yeah, and it's interesting for someone so sophisticated and the way that you're thinking about your program to have the IT/OT gap, is what we call it in our foundations course, our smart building strategist course. That's still going to be a problem no matter how far you are down the smart buildings path. It seems like for anyone listening to this, it's just always something to manage. It seems like.
Yeah. Just when I thought we had it down, that we stumbled across this. I go, there's more we can be doing.
Still more. There's still more. Totally. Dan, what's your number one challenge?
Well, I echo Gerry's thought that there's so many challenges and there are so many opportunities out there. That's very true. And funding, I think, is always a challenge. I think you mentioned that earlier, that how do you compete against other interests within the organization if you've got a leaky roof and leaking into your new construction or even your existing building? How can you justify replacing an existing controller or implement some new IoT device if your roof's leaking or facades needs repairs? That's always going to be a challenge. But I think my biggest challenge, I think a lot of the industry's biggest challenge, is the workforce that you mentioned. And it's sometimes we're building these new complex buildings or new sequences, and it's getting ahead of what the workforce has been used to for 20, 30 years. So we have to keep them within the organization and make it a goal of ours. And to Gerry's point, our opportunity is to continuously improve our training programs and making sure that our staff that are operating and working in the buildings can maintain these new complex sequences and to support the buildings. Because if they're successful, if the people operating the buildings are successful, then the building will operate successfully, I guess. So that's kind of our goal and our biggest challenge right now, which is to retain good workers, good workforce, and make sure they're trained and have the tools they need to succeed.
Totally. Durga, what would you add?
No, I mean, I totally relate with them when he's talking of the roof situations, actually. Like when the funds goes to the roof repairs and we need to do some band-aid on the controls system side. So yeah,
Yeah.
So that what happens. Like I think Gerry and Dan has really brought up really good points on the challenges. It's the same area, I would say. It's like for our case with the small institutions like this, funding is really hard to get, and they focus mostly on the primary things rather than focusing on the backends, like on the smart building of the control systems, because they're working. But we have, when the university says, okay, this is where we need to keep because this provides more revenue than what we try to invest on the controls or something like that. So there's a more weightage on there. The second thing is about the workforce. Like when there's really less workforce and when trying to bring a different technologies into the system, like if you don't have people to work on that, and on the top of when there's no funds, they would be just like sitting there, even they're trying to provide. So that's one being the biggest challenge, seeing there. Yeah, those are the major ones. Actually, if you balance between them and if you're creating a training, if you have resources, funds and resources, we can do anything, I would say.
Absolutely. Yeah. People and money. People and money. All right. Let's close this out with one last round here. So all three of you have something in common in that you're going to be in Denver at the end of September at NexusCon. I'm so excited for you three to meet. For those listening, they hadn't met before. They show up on this podcast and we're just having this conversation. It's awesome. But we're all going to be meeting in person. And I'd love for you guys to each talk about sort of why you're excited about coming. But also, we have one session that's going to be focused on emerging and cutting edge tech. And so I'm wondering what's one or two like 5 years, 10 years out technologies that you'd like to see in that session. Anybody want to go first?
I'll jump in. When I get out and about and get to talk to folks in the wild about smart building stuff, everybody wants to talk about AI, which I'm fascinated in. But what I'm looking for is what's that initial layer of AI that we can apply to our data so that when I'm getting my data out of my HVAC system or my lighting system or any other system, it comes in with all its defects and faults and imperfections and also with all of its value. What's the AI that can kind of clean that up so that I can publish a clean set of data to students, to researchers, to a third party in the cloud killer application, to somebody else's AI application. But as somebody responsible for, some pretty fundamental OT platforms, my biggest challenge right now is just I lack confidence in sharing this data. And as I said before, I want to make it easy for folks to consume that data. I don't want to frustrate them. I don't want to be seen as a bottleneck. But I do feel like I'm missing a tool as part of that process. So kind of the pre-AI layer.
Yeah, we're thinking about having a session, and it's either going to be part of our buyer symposium, which is a closed door session for only building owners, either that or a different session, but a session around what I would like to buy, but I haven't seen it available. And so that might be a good one for that session. Dan, what about you?
Well, I think AI is the buzzword, right? And it's probably going to be talked about quite a bit. And what kind of data do we feed it? Do we feed it our utility data so it can sort of forecast better? Do we feed it our HVAC data and it kind of tells us, well, we should be tweaking, our HVAC equipment, our lighting controls in this certain way, and really, expand outside of just, energy reduction or carbon reduction locally, but maybe paying attention to the grid to understand, all right, is it clean, is it dirty? How do we react to that as an organization, sort of responsive software systems like that. I'm also interested into something Gerry's already talked about quite a bit, which is space utilization, to understand what's out there. How do we better utilize our buildings with a lot of work from home, a lot of remote work, even if it's a few days a week. People are having empty spaces, and can we utilize that or convert that to sort of hotel? And does that help everybody in the organization or change big decisions on maybe we don't build that new building, maybe we utilize or renovate some existing infrastructure? And how can that data help to guide that decision, sort of make it a more intelligent decision? Yeah, and sort of anything really that can move our climate action plan forward is really what I'm trying to get out of it, and talk to other universities and how they're approaching their carbon reduction goals and smart buildings programs, so that we can together sort of collaborate on what's worked well, what hasn't worked well. And, because we're not alone in this world and we should be collaborating. And it's an interesting industry to be in because we compete, but we don't really compete, right? It's like we're all doing fine, and people want to go to higher ed and they want to learn, and that's fantastic. Our problems are very similar. We're aged buildings of various types, a lot of like post-war booms, 2000 booms. So we have different technology, but very similar. So like-minded, like type problems, and how are different universities approaching it. So that's what I try to get out of it.
Awesome. I think I'm mentally checking boxes right now as we're putting together the agenda in the background. Like, are we covering these things that the people want to see? I think we are so far. Durga, what do you think?
Gerry and Dan has already covered most of the stuff. I don't want to reiterate them, but I think the one thing is I'm trying to look at is like a snowflake of the systems, where all the systems converge together at one point, bringing the data on the data layer. So that's the one, because I think still we are struggling how we can connect these systems together, kind of a thing. I think down the line, maybe the technology can help us doing that, integrating all this, where the university can work together on these things. When you're talking about the university point of view, so
okay, yeah, cool. This is all good fodder for me. Also, for those of you that are listening, we're going to have these topics and more, plus just a lot of time for people to have one-on-one meetings, like Dan was saying, with people that are doing the same stuff as them. That's kind of that's the idea. That was always the idea with Nexus, but now we're just going to do it in person. So I want to thank you all for coming on to talk about this and sharing what you're working on. Like you said, Dan, there's competition between universities, between different office buildings, but I think one thing that we like to see is sharing what we've learned, sharing best practices, and that's what kind of accelerates the industry together. So that's what we're here for. So thanks for coming on the show. This will we'll publish this audio, video, and those of you that would like a summary, we'll do a written summary as well on the website of what these guys have said here today, and we'll continue this in September in Denver. Thank you all.
Okay, friends, thank you for listening to this episode. As we continue to grow our global community of changemakers, we need your help. For the next couple of months, we're challenging our listeners to share a link to their favorite Nexus episode on LinkedIn with a short post about why you listen. It would really, really help us out. Make sure to tag us in the post so we can see it. Have a good one.